Continuing on from yesterday, let me get me a clean page. So yesterday we close these doors so you just looking at. Yesterday we did some demos and observed density because we had the ice floating in the water. And then you dissolve some salt. First you looked at the salt and we theorized that the salt would eventually dissolve over time. It's take a little longer, but when you stirred it, it dissolved. Yeah? Yes? I'm shaking your head. And then we tried to put a paper clip on top of the surface, and what happened to it? So what property were we looking at? Density, and which was more dense, the water or the paper clip? Okay, because it sank to the bottom, right? Then we just put a straw in the cup with the food coloring. You saw the water go up the straw. What we're showing right there. Do you remember? Adhesion, good. All right, and then I had you drop some water on a penny. Cohesion with the water sticking together, but it also did adhesion too, right? Because it had to stick to the penny. Is that all? What else did we do? Is that it? That was it? All right. So we're gonna look at thinking about all those qualities that water has, and this planet is mostly made up of water. Do you think those properties play a role in our ecosystem? They got to, right? That's important. So we're gonna look at each of those properties. Let's start with density. All right, so think about our natural earth, and let's think of some examples where density is displayed. Think. Y'all know that song?
Jeopardy.
All right, so think about it. We use an example of density showing ice floating. Does ice float on this earth? It does? Where? Okay, you said ice floats on polar ice caps. All right, so yeah, we can see floating ice, that's an example. Okay, think about some other examples of density. We see density. Huh? Glaciers are still on the earth. So, we talked about convection currents in earth science. In geography, where we said the convection currents happen because of density. The hotter it was lighter, and it got pushed to the top, and the cooler, but still hot, portion gets pushed down because it's heavier. Do you think water does that? Where you have a really warm layer that rises and sinks in different areas?
Yeah.
So where would the water be very warm?
At the surface.
Okay, think about geographic location. Like say we're in the United States. Suppose we went like closer to the equator, like say out one of the islands near the equator. Would they have more sun there than we do?
In the middle.
Yeah, in the middle of the earth.
Yeah.
Would you expect that the middle of the earth to be warmer than, more consistently warm than where we are?
Yeah.
And we know our area is not consistently warm because we have 4 distinct seasons. But say we move to Hawaii, would we expect to have a winter in Hawaii?
Probably in December, ain't it?
No, I'm saying winter as we know it, like snow and cold.
No.
Okay, so we can assume that water will be very warm, right? Because it's being heated up all the time. What do you think would happen to that water? Think about convection of the mantle. It will evaporate, but that's another property we'll talk about. Huh? You said floats or rise to the top? Okay, so the rising to the top, that could be an example of density, because maybe you don't know this, but the water does actually do one big convection. And when it does that, it brings up nutrients. So basically what's on the bottom gets pushed up.
And that brings all the stuff at the bottom.
We call that a big upwelling, because the water is moving. So, and we haven't talked about the atmosphere yet, but warm water moves because it's less dense. It's gonna push something out of the way, and that's how we get ocean currents, okay? So, density affects ocean currents. So if we have a Earth, let's say this is our Earth, and make it all blue. And I have my little lane glasses. And then I say this is my equator, my and then my sun is right here, heating the earth with the rays. So some of those rays are gonna hit the equator direct. And then some hit at an angle. We're in a position where the sun hits at an angle, the rays hit at an angle. So we get good enough sunlight to have some warmth, but we also have variations of temperature. But this area right here always gets heat, so that makes that water very warm. And what happens is it makes the warm water from the equator be pushed up to the North Pole, and then that cooler water gets pushed down to the equator. All right, so that's a big cycling. And this movement, convection current of the water, because it's changing in temperature, makes that water move. And then when this water heats up enough, it's a continuous cycle. All right? So, mantle does this convection. Ocean currents are produced because of this convection. What do you think else is produced because of convection? We have liquid, we have solid mass. What else do you think? Gases. What gases do we refer to on Earth? Oxygen. Okay. Carbon dioxide. So our air is a mixture of all those gases, right? So, do you think that our air will be affected also by changing temperature?
Probably.
Yeah. And this is the reason why we have wind currents. Let's say wind currents. You said jet stream.
Ain't that the same thing?
Well, that's one of the wind belts, jet stream. The one that affects us, though, we'll talk about that when we get to the atmosphere, is, I don't know if you've ever heard of these, the westerlies.
I probably have, but I don't remember.
So all of these happen because there's a difference in density. that makes the air move. Okay? Think about animals. Do animals that live in water, some of them swim, right? So they're moving on their own, under their own power. What about a jellyfish? Does it move on its own power? What is it dependent on?
The currents,
Ocean currents, right? Why doesn't it sink to the bottom?
it floats, or it's just there.
So it's blown up like a balloon, so it has air on the inside, which makes it lighter, right?
They have it on their side?
Well, gas on the inside. You know, they're kind of blown up. I never even thought about what's on the inside of a jellyfish. But it looks like air, like it's a balloon. Can we float on the water?
Yeah. It's enough.
If it's enough, if you know how to do it. You have to relax your body for you to do that. Ordinarily, if we don't do that, we wouldn't float. We just fall, go to the bottom, right? But if you, how many know how to float? Oh, okay. Huh? Oh, okay. Any other instances of density? Can we think about anything else? Think about divers. They have to wear that special equipment when they dive. Why do you think they need that?
So they can breathe underwater.
Well, so they can breathe underwater so they don't die. Water pressure. Okay, also protected from water pressure, or helps them stabilize the water pressure. And this is why they shouldn't ascend too quickly, because they can get a condition called bends, where the nitrogen is pulled out of it's kind of out of solution, the air solution. But as they go deeper, the pressure increases. And with also that increased pressure, density also increases. So animals are suited to that. You know, some of them, they swim, but they also dive for their food. So their body has to be conditioned to do that, change those densities, right? Or else they're gonna die, right? There's too much pressure per square inch pressing on them. All right, let's see. What else can you think about for density? Oh, which do you think is more dense? Fresh water or salt water?
Salt
Fresh
water.
water.
Why?
Because of the,
Huh? What'd you say? You were right. Salt water is denser, but why?
because it's got salt in it.
Right, it has lots of salt in it. In some areas, they have some bodies of water that's very salty, to the point where if you walk in on like we go to the beach, we feel sand, right?
Yeah.
You go to that area, like say the Dead Sea, you feel minerals. You can't walk into the sea without shoes on, because it's minerals down there. All right, so let's think about adhesion. So adhesion. What are some ways that we can observe or some examples we can observe in nature? Dewdrops sticking to the grass. Dew on the grass. Water on spider webs.
Water on windows.
Okay, we're talking about the environment. That's a man-made contraption that's causing the global warming. So in nature, and how it benefits. So how would dew being on the grass benefit the grass? It's watering the grass, right? So giving it some water. And they need it to grow. All right. All right, so this planet is mostly water, right?
Yeah.
Where is the water located?
An ocean.
And oceans, where else?
Lakes.
Lakes, rivers,
Swamps.
swamps. So what makes that water stay in place? Well, one thing is gravity. All right. But in addition to gravity, what are we talking about right now? And what is the water adhering to? If it's in a lake, what is it adhering to? If it's adhering to itself, is that adhesion? So where is the water? What is the water adhering to? The bottom and the sides of the indention, right? So lakes, let's get to the lake, adhere to sides of the lake. All right, so some water is touching the sides of the lake, and then the rest, of course, you're talking about cohesion. They're sticking together. Uh-oh. So we can go ahead and write cohesion. Water and the lake sticking together. So if there is no adhesion force holding the water together in a lake, what do you think would happen to the water? Huh? Spill out? Just flow everywhere, right? Could flow everywhere. Let's see. How does cohesion support the water cycle?
The water condenses together.
All right, water condenses. And when it condenses a whole lot, what happens? So when water condenses, what happens?
It collides.
Forms together like into a bigger water.
Right, a bigger droplet. And then when the droplet is so big, what happens?
It fell.
It falls. As what? What we might be having today, rain. And how does the rain benefit an ecosystem?
It waters the earth.
Provides water, right? For what?
For us and the animals.
All right. And plants, right?
Yeah.
And plants are the beginning of what?
The life cycle.
Right. So we need that the plants for those for the beginning of our water cycle. All right. Now let's see. Y'all have that written because I'm gonna move the screen. I got it written. Y'all supposed to write at the same time I'm writing. With all the pictures you guys drew the other day, I figured you make mention of adhesion with the roots of plants. Y'all didn't say that. Y'all drew all those pictures. Nobody said that. I'm gonna go into the plant, sticking to the sides of the walls of the xylem, phloem, and then the water sticking together as it goes up the root. Oh, y'all drew those pictures when I had you do the images. All right, are we ready? All right, so new page. Let's go to specific heat. So what do we learn about the specific heat of water? What do you remember? Look back at your notes if you need to. And how that, okay, what do we remember about the specific heat of water?
Takes a lot of energy.
It's a lot of energy. Lots of energy. Lots of energy to raise it how many degrees?
50 to 51.
Just 1 degree, right? Somebody said 1? I heard somebody say 1. 1 degree. So if we're going from 60 degrees to 100 degrees, to 61 degrees, it takes about 4,000, it's 4,000 something, I can't remember right now, because I mix it up with the miles, so I don't want to tell you the number, but it's at least 4,000 joules. So it takes that amount of energy, and anybody ever boil something and you accidentally get a drop or two on your skin?
Yeah.
Isn't it very, 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 very hot? Very, very hot. You can actually get second, third degree burns just from water still on. Yeah. Or that energy transferred to something else, like y'all eat oatmeal
No.
or something that's warm. Oh, you eat oatmeal? Don't y'all like oatmeal?
I never had it.
All right. Yeah, so that energy transfers to a food that we're eating, and that food can burn you. All right, so how does the specific heat of water, let me say this. And we also learned from the Amoeba sisters that it takes that much energy for it to change 1 degree. It also takes that much energy it needs to lose. We learned, we watched the video, it lose that amount of energy for the temperature to decrease. So when you have a beverage that's warm, and say you're drinking some, I don't know, what do y'all like to drink?
Red Bull.
No, something that's hot.
Coffee.
Coffee?
Hot cocoa.
Or hot cocoa. All right. Or hot cocoa. So when you make your hot cocoa, it's very hot, and you sit it down for a couple of minutes. Is it immediately cool by 1 or 2 minutes?
No. It's
You said
still
what?
be hot.
It'll still be hot, right?
Still hot.
How long do you think, have anybody ever made some hot chocolate and forgot about it?
Yeah.
No.
Yes.
I did it a couple times.
Let's say you forgot about it for about 30 minutes. Will it be the same temperature as when you first heated it?
No.
But it's still warm enough to drink, right?
Mm-hmm.
Yeah, that's not a drink you want to drink cold. It just tastes good warm, right?
Yeah.
Imagine that hot cocoa being as large as, let's say, our Atlantic Ocean.
Oh, a lot of them had it.
All right? And say it has been heating up all summer long, and now it's the winter time. So would you expect the temperature of the ocean to be cool now because it's winter time?
Yeah.
No.
Yeah.
No. Why do you say yeah? Okay, we just said it takes a lot of energy for either to gain or lose temperature. So just because we went from December 20th to 21, now we're in winter, the water immediately is, that big old body of water now is immediately cold. Think about that. Think about it.
I know what you're talking about, Miss Dawson.
Okay. So we wouldn't expect the water to cool off immediately. It will eventually cool off. And the cycle will begin again where it'll heat up again because we get ready. Spring equinox is today. Did y'all know that?
No.
So it's spring now?
Yeah, officially spring, whether or not the weather outside agrees with it.
Yeah,
On
the
the
weather's coming
date
back.
wise, it is spring. So the water is cooler now. But yeah, it's cooler because it has had months to cool off some. Not as now, we wouldn't expect it to be like ice cold right now, but it's cooler. So, thinking about water taking a while to cool, how would that benefit animals?
Well, like, say a dog. Wait, snail.
Animals that live in the water.
It keeps them like kind of balanced.
Okay, so yes, for animals that live in water, we say aquatic animals, specific heat, right so close together. Specific heat of water keeps the temperature balanced. What would happen if something happened that caused the water? So let's say there's a nice little fishy.
Is it diesel?
Smiling. And he is used to, let's say, 50 degrees Celsius water. And all of a sudden something happens. And the something happened is something that humans do as always. Very rare, it's just a natural thing that happens to Earth. So the humans do something that makes his water go from 50 to 30 degrees Celsius. What do you think that's gonna, and he loves 50 degrees. What do you think will happen if now his environment has changed to 30? Here's his little, he's sad. What would happen to the fishy?
He's sad.
He might die, right? Uh-oh. He might die. Poor little fishy. All right. Anybody keep fish?
I did.
Oh,
That
yeah.
when I was like 8.
Okay. No, I mean I like pets in your house.
Oh, yeah.
Okay.
That when I was
And you have to have that as at a specific temperature, right? If it gets too cold, they can't tolerate that. Same with in nature. So specific heat of water, one thing, it keeps the temperature of the water pretty even that any animals or plants that live in it can survive. All right?
You really did put an X on his eye.
Yeah, because y'all said, yeah, he died. Oh, another thing that we will talk about when we talk about the atmosphere. We mentioned in the others talking about something else earlier about currents. So if this is a landmass right here, let me do a landmass. Let me make it fill it in. So this is a landmass. I'm the only singer in here.
Bye, sing in church.
Oh. Are we in church right now?
Well, we learned about something.
All right. All right, so here is an ocean current going by. All right, what do you think warm represent, blue represent when we talk about water?
Aqua.
Well, okay, talk about water temperature. Cold, right? So we represent cold. So say this is Australia. If we went to Australia, what would we expect the temperature to kind of be?
Hot.
Right. But if this body of water is flowing by these coastal areas, what do you expect the temperature right here to be? If cold water is going by, and cold water, if you're standing by, a body of water, let's say, anybody been to a hot tub?
Yes.
You don't get in it, but you can feel the warmth coming from it, right?
We don't get in it.
I'm saying if you don't get in, you're standing by it, you feel the warmth. Same thing with cool. If it's a cool body of water, it's the air above it is going to be cool. So if a cold current is going by this continent here, what do you expect? How do you think it will affect the coast of this continent?
Change cold.
It'll be cooler. Yes, it won't be cold. It'll make this area cooler than being right in here. So it might be very hot here, but it might be nice. It's still hot, but a nice hot. Not too hot, not too cold, because of this body of water there. All right? Same thing is if, let me do another continent,
South America?
one that's cold.
Oh, Antarctica? Antarctica?
Huh? What are you saying?
Antarctica?
Yeah, I'm trying to draw Alaska. Alaska.
No, that's fine.
All right. So, say for example, we have another current going by, but this current going by Alaska just happens to be warm right here. So,
It'll be warmer.
so yeah, it'll be warmer here. Uh-oh, make it smaller. It'll be warmer, or we say milder. Not as cold,
Not too hot.
not as cold, but it'll be very cold in this area because it's not influenced by the water. So the temperature of the water warms the air above it or cools the air above it. And if it's flowing beside a body of land mass, it's going to affect those coastal areas. Think about it. We can be here in St. Paul's and it's warm, right? It can be hot, piercing hot. If we got in the car and drove to Myrtle Beach, no, not our beach, Carolina Beach, our beach, would it be searing hot at Carolina Beach?
No.
Does that water affect the temperature of the coast? We'd be like very, very comfortable and relaxed sitting out there with the water, right?
Yeah.
Looking at the water. All right. So the last one is, did y'all draw all this? The last one, I'm gonna use this side over here. Universal solvent. What do we say a universal solvent does? Dissolves almost everything. And water is one of those that dissolves almost everything. How does that benefit ecosystems? Yeah, how does it benefit the animals that live there? What can be dissolved in water?
Salt.
Salt.
Okay, and think about as it pertains to the ecosystem. Salt. What else can be dissolved in water?
Sugar.
As it pertains to an ecosystem.
No.
Sand.
Dead plant matter. All right. So when it gets decayed enough, it's gonna be anything that's in it that can be dissolved can be so we say nutrients. So the nutrients from this matter when it's decaying. And what does this dead plant matter nutrients become for another organism? Food. Good. So it can have dissolved food for organisms. We did talk about upwelling that brings all the nice nutrients up, right?
Yeah.
What else can okay, animals live in the water, right?
Yeah.
So we just found out they have food. How do they survive otherwise? So why are we living right now?
Because we have oxygen.
Right. Do animals have oxygen in the water?
Yes.
How do they get their oxygen?
By
Their gills, right? And where the oxygen come from?
in the
In the water. So we have dissolved gases in the water. And specifically, we have the oxygen that they need. Uh-oh. Oxygen for the fishies. They're happy. All right.
They live.
One little happy fishy.
Mhm. So we just mentioned a few properties, a few examples of real life application of the properties, but the list is actually endless. The role that those properties play. All right. When you finish that, I'm gonna give you my final question for you to answer.
Fishy.
So think, and I want you to think about this, the different properties: specific heat, density, adhesion, cohesion, and what was the last one? Oh, universal solvent. When you answer this final question. Alrighty, are we ready?
Yes, ma'am.
Y'all drawing my little fish at the bottom there? He's gotta make sure you put the smiley
Is that
face.
Nemo?
No, Nemo has got a stripe, don't he? How many times? 2 or 3? He did count them. Alright, so our final question here. Which property and we're talking about the ones we just talked about. Do you think is most important? In an ecosystem. Or for an ecosystem. In ecosystem, for ecosystem. And I want you to explain why you chose that one. So if you choose specific heat, I think specific heat is the most important. Then you explain why. If you say density, I think density is the most important for an ecosystem. Then explain why. All right?